Hello friends, this is the fourth video in the CSES sorting and searching video series. In this video, we will be solving the problem number 4, which is concert tickets. The problem statement is, there are n concert tickets available, each with a certain price. Then m customers arrive one after another. Each customer announces the maximum price they are willing to pay for a ticket. And after this, they will get a ticket with the nearest possible price such that it does not exceed the maximum price. Input. The first input line contains integer n and m, the number of tickets and the number of customers. The next line contains n integers h1, h2, hn, the price of each ticket. The last line contains m integers t1, t2, tm, the maximum price for each customer in the order they arrive. We have to output in output we have to print for each customer the price that they will pay for their ticket. After this, the ticket cannot be purchased again. If a customer cannot get any ticket, print -1. Constraints are n, m is greater than or equals to 1 but lesser than or equals to 2 into 10 raised to power 5. Hi, ti is greater than or equals to 1 but lesser than or equals to 10 raised to power 9. Then we are given a sample case. First, let's see what the problem statement is. We are told that there are total n concert tickets which we are having, which we can sell to the customers, and we are having m customers. All the customers have announced a price which they are ready to pay for buying ticket, and we are also aware about the ticket price for each the ticket. All the tickets are having their own price. So first we are given the value for n, which is the number of concert tickets, then the value for m, which is the number of customers. Then we are given n different integers, each of which are the prices of different tickets. Then we are given m integers, each of which are the prices which the ith or let's say jth customer is willing to pay. So in this case, what we have to do is we have to allocate tickets to the customers in such a way that a customer should get a ticket whose price should be nearest to the price he is ready to pay, but it would be lesser than or equals to. Basically, it should be affordable by the customer, but at the same time it should be closest to the price which he is willing to pay. If a customer cannot get ticket, we will print -1. If he or she can get ticket, then we will print the price which he will pay for that ticket. So first, let's see what the sample case is. So let's say this is the sample case. So we are told that there are 5 customers, 5 tickets and 3 customers. The first ticket is of ₹5, then 3, then 7, then 8, then 5. The customers are, the first customer is ready to pay ₹4. So can we sell ticket to the first customer? We will try to find the value which is closest to the price he is ready to pay and is affordable for him. So 5, is this affordable? No. 3, this is affordable, but is there any other ticket which is more expensive than this but is affordable by the customer 1? No. So we will sell this ticket to the customer number 1. And this way our answer will become, let's say we are having 3 customers. So first customer, this is the second customer, and this is the third customer. First customer bought the ticket for ₹3, so we will print 3 for him. Then second customer is willing to pay ₹8, which would be the ticket closest to the price he is willing to pay and is affordable by him. The ticket number 4, which is of exactly the same price which he is willing to pay. So it is affordable by him and is closest to the price he is willing to pay. So for the second customer, we will print 8. Then the third customer, he is willing to pay ₹3. Can we sell any ticket to him? First ticket, no, it is not affordable by him. Then second ticket is already sold, so we cannot sell. Third ticket, no, because it is not affordable by the customer. Then fourth ticket is already sold, and fifth ticket is also not affordable by the customer. So we will print -1 for the third customer. Now let's see another test case. Let's say this is the another test case. We are having 5 customers. 1, 2, let's say 3, 4, and at last the 5th customer. First customer is willing to pay rupees 14. Can we sell any ticket to him? Yes, we can sell any of the 3 tickets to him. But which one is most closest to the price he is willing to pay? The second ticket. So we will sell him the second ticket for rupees 8 because that's the price for the ticket. Then the second customer is willing to pay rupees 8. Can we sell any ticket to him? We can sell all the 3 tickets to him. This one is closest to the second customer's price, but as this ticket is already sold, so we cannot sell it again. So we will sell either first or the third ticket to the second customer. So let's say we are selling the first ticket to the third customer. Choice is asked because both the tickets are having the same price. For the second customer, the price will become 5. Now can we sell ticket to the third customer? Third customer is willing to pay rupees 2. No, we are not ready to sell. We cannot sell any ticket to the third customer because the price he is ready to pay is too lesser. So we cannot offer any ticket to him. So for the third customer, we will print -1. Then for the fourth customer, he is willing to pay rupees 5. We can sell third ticket to him, which is of rupees 5. So for the fourth customer, the output would be 5. Now for the fifth customer, is there any ticket left? No. All the 3 tickets are sold. First ticket is sold. Second ticket is sold. Third ticket is also sold. So we cannot sell any ticket to him. Why? Because we are not having any ticket. So we will print -1 for this customer. Now what could be the approach for solving this problem? If you will simply think, what we are trying to do is we are storing all the ticket prices. Then we are trying to find a ticket price for every customer which is lesser than or equals to the price which is customer is willing to pay. So what we could do is, if we can store all these value and find a lower bound would return us a value which is greater than or equals to this particular value. So which is greater than or equals to. So if we will move our iterator one step back, we would be having a value which is either equal to the price which is this which this customer is willing to pay, or which is just before this value, our ticket price which is just lesser than this customer's price. So that's what we want to find. So what we can do is we can create a multi-set and store all the ticket prices in that multi-set. Let's see how we can approach the solution for this problem. So what we can do is we can create 4 cases. Firstly, we would be creating a multi-set and storing all the ticket prices in that multi-set. After that, we will check for every customer that if the ticket price multi-set is empty, that means all the tickets are already sold. So we will print -1 and continue for the next customer. Or else the case 2 could be that we find lower bound of CP. The price which this customer is willing to pay, we will find the lower bound for this customer. Then we will check if this lower bound is the first element of our TP, which is our ticket price multi-set. If this is the first element and is greater than CP, this ticket price is larger than what customer is willing to pay, because this is the least expensive ticket, the most affordable ticket, and this is not affordable by the customer. So in this case also we will print -1. Or else the case 3 could be the lower bound of CP is greater than CP. That means the ticket which we found is not affordable by the customer, but it is not the first element. So that means the ticket before this ticket, the ticket which is just whose price is just lesser than this particular ticket, would be satisfying for this customer, would be affordable by this customer. So we will decrement our iterator in that case and then print our answer, because the ticket price is greater than what customer is willing to pay, but the ticket price for the ticket previous to this ticket would be satisfying for the customer. Or else it could be that the ticket price, the lower bound of CP, which means the ticket which we found is equal to what our customer is willing to pay. That means this ticket is affordable by the customer. Then we will print our answer straightforward. And at last, after checking for all these 4 cases, we will delete this particular ticket if it's the case 3 or case 4, which means if we have sold the ticket, then we will delete the ticket. Let's see how we will write the code. So firstly, we will take 2 variables, integer t and c. Then we will take input for t and c, which are our number of tickets and customers. Then we will create a vector of integer type cp of size c, which is our customer price vector, which will store prices which our customers are willing to pay. Then we will create a multiset. Why we are creating multiset? Because there could be 2 tickets with the same price. So if we will create a set, then we would face that issue. Multiset tp. Then what we would do is for auto reference I from cp, we will take input for c input for I, and because ticket prices would are given previous to are given before the customer prices, so we will take ticket prices first. For integer I equals to 0, I is lesser than t, I plus plus. Let's say we have a variable temporary. We will take input in temporary for a particular ticket price, and then we will insert this ticket price in our tp multiset. After taking these values, what we would do is we will process all the customers one by one. For int I is equals to 0, I is lesser than c, I plus plus. Now if tp dot empty, that means if tp is already empty, then we cannot sell any tickets because all the tickets are already sold. In that case, we will print -1, and after that we will continue for the next customer. Else the second case could be if let's say we find the in all the rest of the 3 cases, what we would do is firstly we would find the lower bound. So tp dot lower bound for the ith customer's offered price. Whatever price the ith customer has offered, we will find a lower bound for that in our tp multiset. If it is equals to tp dot begin, that means this is the most affordable ticket and value of this ticket is greater than what our customer is willing to pay. That means this customer can't afford any ticket, so we will print -1. After that we will move to the next line. Now the case 3 is, let's say if if dereference it is not equals to cp of I, whatever this customer is willing to pay, it is not equal to what our ticket price for this particular ticket is. That means if it is not equal, that means we are having ticket price higher than our cost customer offering. Whatever our customer is offering for this ticket, it is lesser than the price of this ticket. So in that case, we will decrement our it by 1. This is the case 3. Then for case 3 and case 4, 2 things are common, which are firstly printing our it and then deleting our it, because this ticket has been already sold. So we will be deleting our ticket, tp dot erase IT. So we will delete this ticket and finally we will return 0 from our main function. So let's check it for the sample case. Let's check this code for the sample case. It is working correctly. So let's try to submit it. So our solution is accepted successfully. If you still have any doubts or any queries, you can ask them in comment section.